Ephesians 6:12 tells us, "For we do not wrestle against flesh and blood, but against principalities, against powers, against the rulers of the darkness of this age, against spiritual hosts of wickedness in the heavenly places." The war is not with specific individual people. It is with a belief system whose goal is to bring darkness, spiritual darkness, and to enslave the planet. So we have to stand firm. There are many ways in which we're at war, and as we've been studying the last few weeks, one of those has to do with the ideology of creation and evolution, which is the subject we're studying. But above all, we have to remember that the flower fades, the grass withers, but it is the Word of our God that stands forever. So before we begin in our continuing study on creation and evolution this evening, let's bow our heads that we can be in fellowship filled with the Spirit and ready to study His Word. Let's pray. Father, we thank You for the truth that we have in Your Word, that this is a truth that we can rely on upon everything else, that we are to walk by faith and not by sight. We are to walk by means of faith and trust in Your Word, and when that faith and trust in Your Word exceeds what we may learn through empiricism, through science, through rationalism, that is when we are walking on the basis of the truth of divine revelation. We pray that we might be challenged by the things that we study this evening to have greater confidence, greater faith in what Your Word teaches us, despite the propaganda of the human viewpoint cosmic system surrounding us. We pray these things in Christ's name. Amen. We're continuing our study in Genesis, and in the previous 2 lessons, in this one I've done a 3-lesson series just focusing on creation and evolution. But in these 3 lessons, what I'm doing, rather than dealing with a lot of Scripture, we went through, I believe it was 13 lessons of scriptural analysis in Genesis chapter 1. And now we are taking the conclusions from Scripture, and over against those conclusions, we're looking at what human viewpoint teaches under the concept of evolution, and we looked at the foundations and how evolution challenges the basic foundations of Christianity. It is a complete contradiction to Christianity and what the Bible teaches. There's no room for compromise. We saw various differences there. Last time we looked at inherent problems in what evolution teaches about man and the background of man and the nature of man. And this evening we're looking at what I think is the core issue in the entire battle. And that has to do with time, dating, the age of things. In evolution, it follows the principle of time plus chance equals everything. The view of the evolution is that if you just give us enough time, anything can happen. If you just add millions and millions and millions of years just under the laws of probability, and we saw that that is really a fallacious argument 2 weeks ago, that if you just give it enough time, anything can happen. If you have enough time, eventually order will come from chaos. The mantra of the evolutionist is that there are billions and billions of years, and this phrase is repeated again and again by the propagandizers of Darwinism. We hear it from news broadcasters. We hear it from science teachers, museum docents. You hear it from the tour guides at the national parks again and again and again in all of the brochures in National Geographic and all the charts. It's billions and billions and billions of years, and you see it again and again and again until you're completely desensitized to this and come to realize this must be true, because if this many people who have this many PhDs believe this, then there must be some solid evidence behind this, and it must be true. The universe must be billions of years old. It is this issue of time which almost single-handedly challenged and brought down the reign of biblical orthodoxy over science at the end of the Enlightenment period. Up till the end of the Enlightenment, which I would place somewhere in the late 1700s, most of the scientists believed the Bible to be true. They believed there was a literal worldwide flood during Noah's time. They believed that the earth was a young earth, that it was not any more than 8,000 or 10,000 years old. But once you have, due to the Enlightenment, the scientists cut themselves loose from biblical infallibility, then they began to analyze the data of nature from a completely autonomous framework. And once they came up with the ideas and alleged evidence that the earth was 35, 40,000 years old, then that immediately challenged what the Bible said, and they used that to try to prove that the Bible was wrong. It is the issue of time. The fact that somewhere they needed to come up with 35 or 40,000 years, at least in the early 1800s, which fueled the accommodationist position. Now remember, the accommodationists are those that have, we believe the Bible, but we also think that science is correct in all of their conclusions, so we have to somehow merge them together, whether we're talking about theistic evolutionists or those who hold to the day-age view, or the progressive creationism of people, biblical scholars like Norm Geisler and Hugh Ross, who in many areas may have good things to say, but in this particular area have sacrificed and compromised biblical truth on the altar of science. Their contrast is clear. It's between divine viewpoint, which says that the earth is somewhere between 6 to 10,000 years, going back to the beginning of the restoration in Genesis 1:2, versus human viewpoint, which says it's billions and billions of years. Now, if you want to have some idea of how, if the earth is 7 billion years old, of how many years that is, I'm going to take my Bible here, and my Bible has about 1,500 pages in it. So that would take 4 Bibles. Now that's about 1.5 inches thick. Now you take 4 Bibles stacked up there, would be about that high. That would equal to 6,000 years, going back to taking a literal date on creation. Now let's turn it sideways. Okay. We'll point it over towards New York. Manhattan, Times Square is about 150 miles from here. This much room represents 6,000 years. All the way to New York, 150 miles away, represents 7 billion years. That's the difference that we're talking about. This is a radical difference in time. This is not something that you can come along and just try to fit the two together. They are opposing views at every single point. You cannot merge them. You cannot compromise. You can't figure out ways to make one fit in to the other. So as I've said, time is a critical issue, and that is why this matter of dating is so important to understand, because people say, well, what about the rocks? They say that the rocks are 10 million years old or 800 million years old or 2 billion years old. How do we know? So tonight I want to look at the dating techniques. Now earlier I've looked at some of the what I would call uniformitarian time clocks. Now what I mean by a time clock is the idea that well, let's just look at the beginning here. Dating of anything is based on 4 basic principles. No matter what scheme you're talking about in dating, there's 4 basic principles. First of all, you can observe the present condition of a rock or a process. And that's science. You take a look at a rock, you observe it, you look at what the elements are, you break it down, you weigh it, you measure it, you take its temperature, all of these things. You categorize it, what kind of rock it is. Observing the present condition of the rock that's good science. That's the starting point. The second principle of dating is that we can measure the current rates of any processes that are operating in that rock or in that system. We can measure the present rates, the current rate of any process in that system. So if there are any elements in that have radioactive elements, where there is a breakdown of those radioactive elements, you can measure the rate of that breakdown, and that is also science, because remember, you are measuring the present rate. That is, you know, that's what's happening right now. In June of 2003, it is breaking down at this rate. That doesn't tell you anything else. It can't tell you what the breakdown rate was 100 years ago, 1,000 years ago, or 5,000 years ago. All you can do is observe what's happening right now. That's good science. The third principle is that we can make certain assumptions. This is where we have to be careful. We can make certain assumptions about the past history of that rock or system based on current realities. And this is called building a model. But this is where you have to recognize their assumption and say, well, if these processes have remained the same, then this conclusion would follow. But you don't know that that process has always been the same unless there were people there observing it and reporting that process 100 years ago, 1,000 years ago, 5,000 years ago. And then the fourth point, which is where the system falls apart, is that we can calculate, based on present processes, the length of time a system was in operation. But see, this is the very issue, because the third principle will bring in for the evolutionist a uniformitarian principle, that this process has been the same throughout all of time. Now, uniformitarian geology is falling on hard times, and there's more and more geologists who are beginning to accept principles of catastrophism. And in the past, I've gone through various types of clocks, and that is you can measure certain rates, such as at the mouth of a river, it lays down silt at a certain rate, so you can extrapolate from that how long the river has been there. You can also look at the moon, and it picks up a certain amount of cosmic dust per year, and so you can extrapolate back that certain principles that 100 years ago there would have been a certain amount of dust on the moon, and we've gone through numerous clocks, and we've shown that they don't give consistent data. They vary from anything from an age of the earth, from anything from 3,000 years to 10 billion years. No two of these measuring devices seem to indicate the same thing. But that's one type of measurement, and that is different from what is called radiometric dating, which has to do with dating the radioactive elements within something. So what we realize here is when we date something, it's based on certain assumptions. Those assumptions are three. First of all, that the rate has always been the same, never slowing down and never increasing. That's true for any kind of dating system, even radiometric dating. The rate has always been the same, never slowing down or increasing. The second assumption is that nothing has been added or taken away from that specimen. There's been nothing added to it or taken away from it. And then the third issue is the assumption that there was none of a certain element there to begin with. There was none of a certain element there. So you have to ask certain questions. Has the rate always been the same? Has anything been taken away or added to the specimen? Or was there any of this element there to begin with? I mean, if you don't know what was there to begin with, how can you determine today how much has been added to it? The point is that all we know with certainty is what we observe in the present. That's the principle. All we know with certainty is what we observe in the present. Now let's get an example of this so you can see one practical application of this principle, and that's at Niagara Falls, something not too far away. Maybe some of you have been there. Niagara Falls is a location where Lake Erie dumps into Lake Ontario. The falls erodes the rock underneath at a rate of 4 to 5 feet per year. That means that each year it moves closer and closer to Lake Erie at the rate of 4 to 5 feet per year. Now, the first time I went to Niagara Falls was in probably 1957 or 58. I was about 5 years old. Since that time, the falls has retreated 200 feet. Now, the falls, Niagara Falls, is now 7 miles from Lake Ontario. Remember, it's backing up towards Lake Erie. It's now 7 miles or 37,000 feet from Lake Ontario. Now, it's a simple matter of math to figure this out. If it is receding at the rate of 4 or 5 feet, let's just say 4 feet, 4 will go into 37,000 about 9 times. So a little over 9 times. So that's about 9,000 years. So you can say that if the rate of erosion has been the same for the last 9,000 years, that 9,000 years ago the falls was dumping directly into Lake Ontario. But is that correct? I mean, how do we know that? We can only measure the process today. Has anything occurred in the last 1,000 or 9,000 years that might speed up that process? For example, was there a downward tilt of land at the very beginning where the two came together, which would indicate that the rate of erosion at the beginning would have been much faster? Furthermore, what if there was more water running off at the beginning than there is today? Now, remember, if you're a believer in the Scriptures and you believe there was a universal worldwide flood, then you would have to assume that, yes, at the beginning there was much more water. The volume of water was much greater. And not only that, but the sediment that had been laid down by the flood was much more recent, much looser, and therefore it would erode more easily and more quickly. Therefore, the rate of erosion right after the flood would be much faster than it is now. So all of these figures would enter in and would affect your understanding of the timing. Now here's a map, a rough illustration of the falls. This darker line right here is where the Niagara Falls exists today. Actually, this illustration came out about 20 years ago, so it's moved back a little more than that. The dotted line here represents the location of the falls in the early 1800s when Charles Lyell, who is the father of uniformitarian geology, observed the falls at that time. Now, Lyell observed it for a short time, and he estimated that erosion was only at the rate of 1 foot per year. Well, if it's only eroding at the rate of 1 foot per year, then that would mean that the falls were 35,000 years old. And he used that date to challenge the veracity of the Bible. I mean, the Bible would say the earth is only 8,000 or 9,000 years old. That is how the assumptions work when measuring certain types of geological events. Now, what I want to focus on this evening is an analysis of radioisotope or radiometric dating. And this is where all of the dating takes place. People are more familiar with carbon-14 dating, but you also have potassium-argon dating, and you have various other kinds of dating that is used, measuring the rate of the breakdown of the half-life of radioactive elements inside of a rock. So at the risk of causing any of you great boredom, we're going to go through this because it's important to understand what underlies these dates. First of all, we have to recognize that the only rocks that can be dated by this method are igneous rocks or metamorphic rock. These are rocks that were once extremely hot, or they were heated up, perhaps the melting point, for example, in a volcano, and have since cooled into solid rock. At this time, there's no method that has any reliability on dating anything in sedimentary rock, which is what is laid down on the surface of most of the planet, or limestone or sandstone. They do not contain the right elements. The assumption in radiometric dating is that melting, when you heat up these elements to that level where the rock melts, resets the time clock. And so that the age clock that they're measuring, the breakdown of those elements, is reset to 0, and the date reflects the time from the cooling of the rock to the present. Now, that's the assumption, that the time clock is completely reset. Now, this appears to be a testable assumption. What I mean by that is that we have volcanoes that erupt all the time, and there are areas on the planet's surface where we have, within human history, the records of certain volcanic action in Arizona, in Hawaii, in South Pacific, and other areas where we know approximately, within a few hundred years, when these volcanic eruptions took place. So we can go there, you can take the rocks there, and you can perform tests on them to see how old those rocks are and see if your system works. And the principle is, if you know the date of the rock and you can test the theory, the dating system against that, if it doesn't come up with an accurate date there, then you know you can't trust it when they're extrapolating to hundreds of millions of years or billions of years. So let's try to understand, if we can, the basic methodology that's used here. rocks are analyzed by looking for certain elements or compounds in the rock which breaks down over time into other elements or rocks. Now what they're looking for is a radioactive element such as U-238, and here we have a chart showing the breakdown of a U-230 uranium-238 atom to an iron-206 atom. As the uranium breaks down over time, it eventually decays into a stable isotope of lead. The U-238 atom in the top left-hand corner is called the mother element, and the iron 206 element down, or lead 206 element on the right is the daughter element. The length of time that it breaks down is called a half-life, and it goes through various other elements in the process, from thorium-234 to tactinium-234 to uranium-234, and back to another isotope of thorium through radium and radon and various isotopes of polonium and lead until it reaches a stable element of lead-206. Now, this entails, but dating this and determining the time entails certain assumptions. Now, if you can figure out in the rock, you have this rock, and there's some uranium in that rock, and there's some lead in that rock, and you can measure the amount of lead in the rock. You know exactly how much is there. Now, you think you know how fast or how slow the uranium decays into lead. Then you can figure out from the amount of lead that's in the rock how old that rock is. That's the idea. You start off, you have some uranium and some lead. You can measure the amount of the lead. You know what the rate of decay is. So therefore you can extrapolate back and to figure out how long it took for the uranium to break down to produce that much lead in the rock. But see, there are a number of hidden assumptions here that have to be addressed. The first assumption is that the rate of decay must have always been the same. The rate of decay must have always been the same. Now, among creation scientists, there is a debate here. There's a difference of opinion. And one view is that there really hasn't been anything to date to demonstrate that outside forces can change this decay rate. That's one view. The other view is that yes, these decay rates can be altered through certain studies. When exposed to various types of radiation and X-rays, this view suggests that this will change the breakdown rate. For example, if a massive amount of radiation were to bombard the primordial soup and the early Earth as postulated by evolution, causing the U-238 to speed up, its half-life would be shortened due to radiation. So it would speed up the process of decay. But how would a scientist today know that something happened, let's say, 800 million years ago to speed up that rate? How long was that rate quickened, and when did it stop? And then what if the radiation that caused that decay rate to speed up, but before that the decay rate was twice or three times as slow as it was after that radiation event? In other words, and then if you come to the theory that Stephen Jay Gould proposed, that there's no real evidence of gradual evolution, you have what he proposed was punctuated evolution, that some event just sort of blasts the Earth and all of a sudden there's a leap from one set of species to another set of species, that this happens very quickly. And under his theory, there would be continuous or regular massive bombardments of X-rays that would change the setup all along. So that means that evolution would have a problem. It can't have its cake and eat it too. If massive radiation bombardment is needed to begin life, then that would invalidate the dating system. But let's assume, just for the sake of argument, that this assumption is valid with certain reservations, that the rate of decay will stay the same. There are still other assumptions that have to be addressed. The second assumption, this is where we start having problems. The second assumption is that the rock initially contained none of the daughter element. You start off with uranium, you have some lead, and what you're trying to do, remember, you can measure how much lead's there, so you're going to try to figure out how long it took for that uranium to break down into lead. Well, they're assuming that at the very beginning there was no lead in the rock to begin with. But see, they don't know that. For example, if it takes 10 million years to produce 1 milligram of lead from the decay of uranium, and you find a rock that has 1 milligram of lead in it, you would conclude that that rock's 10 million years old. But the problem is, what if God created that rock yesterday with 1 milligram of lead in it? Or what if He created it sometime in the past with only a half a milligram of lead in it? I mean, we don't know how much lead was in the rock to begin with. So that means by assuming that there was nothing there to begin with, you're going to drastically affect your conclusion. Furthermore, what if there were some cataclysmic process or reaction that took place in history that caused some lead to leak into the rock, or in the formation of the rock? Remember, this is rock that's been heated up. It comes out of a volcano. What if something happens that caused lead to get into it, or, on the other hand, to leach out? What if at one point there was actually more lead there and it leached out? You would still have erroneous conclusions. Furthermore, how can a modern scientist today differentiate between the lead that God created in that rock to begin with and that which developed over time as a result of the breakdown of the uranium? So every dating technique assumes that there was no pre-existing daughter element, and that means that their whole dating scheme is nothing more than a pure guess. That's the problem with Assumption 2. Assumption 3 gets a little more interesting. Assumption 3 is that the rock specimen has never ever been contaminated. That means that you've got a pure sample or a pure specimen of the rock, that there were no processes at any time that caused the loss of any element in that rock, or that any other elements leached into the rock. Now, to be fair to scientists, a lot of effort is made to use as clean a specimen as possible. I mean, they know there are problems. They're very much aware of the fact that there are problems. But they try to use as clean a specimen and uncontaminated a specimen as possible. But you see, that's not consistent with other known scientific realities. And what they run across is vast numbers of inconsistencies. In fact, there was an article published by, I believe it was Douglas Woodmarappy, back in I think it was 1980, in the Creation Research Society Quarterly, where he listed over 300 examples of dating where the specimens produced widely divergent and contradictory ages. And the problem is that if it doesn't fit their view of what kind of rock it is and how old it should be, then it's assumed that it's contaminated. Why? Because it doesn't fit their old Earth model. See, they have an agenda. The Earth is 7 to 18 billion years old, so if we test this rock and it doesn't fit our pattern, then, well, we've got a contaminated specimen. They assume then that nothing could have gone into the rock which would alter the decay rate and thus give them an erroneous date. So if anything speeds up or slows down the process, then their dating conclusion is completely off. Now, in critiquing this, we have to realize that, first of all, there is no such thing in nature as a perfectly closed system. That's a nice concept in the laboratory, but that doesn't work out in nature. There's all kinds of things bombarding the rocks, and especially if you're assuming the Earth is 7 to 18 billion years old, that would mean that every molecule in the universe has been in at least 4 different substances since the Big Bang. That's the conclusion of evolutionists. Every molecule has been in at least 4 different substances since the Big Bang. Well, that would pick up a lot of contamination over the time. So you can't have it both ways. You can't have molecules in flux and shifting through 4 different substances over the period of billions of years and also have a closed system. You have to pick one or the other. Rocks do get contaminated. Things seep into them. They're exposed to radiation. Rocks change when they are exposed to wind and water. Some things are leached out and other things seep in. Now, when analysis is done on some rock samples that are considered to be uncontaminated, and the dates either don't agree with each other, you might pick 3 or 4 samples from a volcanic lava bed, and they each come up with a divergent age. If they don't agree with each other, or with estimated dates, you're assuming based on an evolutionary time scale that that rock is 1.2 billion years old because of the kinds of fossils or because of the strata that it's in. If it doesn't fit, then the results are thrown out as contaminated. Let me give you an example. Dr. Andrew Snelling, who is a professor of geology with the Institute for Creation Research, studied the published dates and isotope ratios from a uranium deposit in Australia. This is what he writes in his conclusion. The above evidence conclusively demonstrates that the uranium-lead system, including its intermediate daughter products, especially radium and radon, has been so open with repeated large-scale migrations of the elements that it is impossible to be sure of the precise status or history of any piece of pitchblende selected for dating. Let me read that again. It's impossible to be sure of the precise status or history of any piece of pitchblende selected for dating. In other words, there are inconsistencies throughout and in every sample. So the question we should ask is, if leaching and contamination can occur which cannot be visibly detected, then how do we know that they haven't occurred in other apparently clean-looking samples which come back with problems? So we have to assume that there's no such thing as an uncontaminated sample. And if it's been contaminated, then there are going to be problems. The point is that if there's any conflict or problem in the results, the dating that doesn't fit the geologic scheme is thrown out. Evolutionist S.S. Golditch, in an article in the Geological Society of American Abstracts, wrote, this was dated in about 1981, he wrote, 15 years ago, radiometric age determinations on minerals and rocks were so startling that absolute age became a password. Intensive research with successive improvements in the potassium argon or rubidium, strontium, and uranium lead methods, however, revealed that geologic processes influence isotopic systems and that the age measurements are analytical values that commonly require geological interpretation. Let me read that again. That's science gobbledygook. The age measurements are analytical values that commonly require geological interpretation. In other words, what finally determines the age produced by the radiometric dating is the geologic timetable. Now, the geologic column and the geologic timetable was developed in the early 19th century before we knew anything about radioactivity. And so the rock has to fit that timetable, and if they date it and it doesn't fit, if there's some sort of inconsistencies in the dating, then, well, that was a contaminated specimen, and so we're not going to use it. And that's what he admits, is that dates require geological interpretation. Now let's look at some examples around which demonstrate that there are great fallacies in this dating system. The first example I want to use is Sunset Crater, which is in northern Arizona. This is known to be a recent volcano. In the lava beds, there are Indian artifacts and remains which indicate that there were Native Americans or Indians living in that area. Doesn't seem like they were killed by the eruption, but their villages and their agricultural sites were buried during that eruption. And so from what's left there, we can date the time of this activity at this crater to some 900 years ago. There are several lava fields there. Furthermore, tree ring dating in the area accurately dates the eruption to about 1065 AD, so roughly 1,000 years ago. And we can pretty much rely on that date with plus or minus probably 100 years. Now, the two lava flows that are there, remember, we know when this volcano occurred. The two lava flows have been dated by the potassium-argon method. Now, remember, I'm going to write these numbers up on the overhead so you can keep track of this. The eruption was in 1065 AD. But according to the potassium-argon method, the lava flow gave ages of 210,000 and 230,000 years ago. Quite a difference. Well, how do they explain that? Well, the explanation is that, well, there was excess argon in the lava. Well, it's true that there were higher levels of argon 40 found than were expected, but that's really not much of an explanation. I mean, if you're going to have a consistent system, it's got to work. Another example is in Mount Rangitoto in New Zealand. That was dated by radiocarbon studies of the trees, and that the eruption there occurred about 300 years ago, so that would be about 1700, AD 1700. But the potassium-argon dating on those rocks yielded a date of 485,000 years ago. So you can see it doesn't seem to be that reliable. Then we come to the great geologic laboratory for the North American continent and the Grand Canyon. Now, numerous volcanic eruptions have occurred on the Grand Canyon's north rim since it was first eroded. So according to the evolutionary timetable, that would be within the last 1 million years at most. But in every case of testing, the lava seems to be much, much older than that. For example, at one formation called Vulcan's Throne, the potassium-argon date there yields the youngest date in all of Arizona, and it yields a date of about 10,000 BC. So let's kind of keep that in our minds. One dating is 10,000 BC, and this seems to be fairly accurate since this particular eruption at Vulcan's Throne is the most recent and postdates all of the other rocks in the canyon. Indian legends also tell the eruptions of various volcanoes in that vicinity, but Indians have only been there a few thousand years, so if this was witnessed, then that puts that date in question itself, because there seems to be living legend that this was much more recent than that. Furthermore, there is a mineral, olivine, that is found at Vulcan's Throne, and an additional age test on the olivine indicated that it had a low potassium concentration, but nevertheless, when the test was run, it had a high argon concentration and came up with a date of 117 million years plus or minus 3 million years. So that's 117 million years. Now that's quite a difference between 10,000 and 117 million. Now there's a problem here. The explanation for why there's such a discrepancy here is that there was some sort of mineral pod in that area which led to an excess of argon and therefore tainted the evidence. But the problem with that is that The assumption is, remember at the very beginning I said it takes molten rock to date this. And molten rock, they're assuming that the rock resets the date. Well, if there's some kind of a pod there that introduces argon into the system, then it didn't get the date reset back to zero. Once again, that would invalidate the whole theory. Another example is in Hawaii. At the, I'm not sure my pronunciation here, the Capalehu flow at the Hualailai volcano, which erupted in 1800 to 1801. So we know that that was about 200 years ago. Now that's a little too recent to have produced much argon or helium, but the one particular study came up with 12 dates for that eruption, ranging from 140 million years, 140 million to 2.96 billion years. The average date from these 12 samples was 1.4 billion. 1.41 billion. Now this occurred 200 years ago. Now they've tried to jump through hoops to try to explain the discrepancies there. Another example, Salt Lake Crater on Oahu is thought to be less than 1 million years old. And according to the evolutionary scheme, one of the methods produced an age of less than 400,000 years, which they called the real age, but 16 other tests came up with an age between 2.6 million and 3.3 billion, which is quite a spread. The average being 845 million, not just 1 million. It's generally thought from other geologic evidence to be less than 1 million years old. So once again, the system produces great inequities. Another event that's thought to produce some consistent dating would be volcanic events in the oceans. And the question there is, does water pressure really make a difference? And once you look at one study at Mount Kauai, again at Hawaii, the lavas erupted probably less than 200 years ago. But repeated samples taken from a depth of about 4,600 meters gave a potassium argon age of 21 million years, and samples taken at a depth of 3,400 meters brought the age to 12 million years, and those taken from 1,400 meter depth produced an age of 0 years. So obviously water pressure would have something to do with contaminating the evidence. So how much? And remember that if we believe in a worldwide flood, that would certainly put enough pressure on rocks to taint all of the evidence. So let's just review this. Remember, the theory here is that if we have rocks of known age, and if radioisotope dating doesn't work on rocks of known age, then if we have rocks of an unknown age, then we can assume that radioisotope dating doesn't work on those rocks either. Just simple logic. So as we look at these assumptions, we realize that the assumption of uniformity is not reliable in normal geologic processes, but seems to be affected by a number of different factors. Now, the underlying assumption here is really assumption 4. And assumption 4 is that the Earth is at least old enough for the present amount of radiogenic lead in a specimen to have been produced by the present rates of uranium decay. Now, that's a long sentence and it's complicated, so let me break it down for you. The assumption is that the Earth has to be old enough for the present amount of lead out there to have been produced by the present rates of uranium decay. The assumption here is the Earth has to be old. See, they're assuming the conclusion, and it's hidden in their other assumptions. They assume it has to be old, and then on the basis of this precondition, they have problems. So this assumption is the backdrop for the entire method. Basically what they're saying is, since the Earth is old, radioisotope dating can help us determine exactly how old it is. but we have to remember that therefore the whole methodology is grounded in a fallacious assumption about the age of the earth, so it is useless to use any of these dating methods in testing between an old earth view and a young earth view. Remember what I said when we started Genesis, that as we look at the conflict with science since the middle of the 17th century, and science started coming up with data that allegedly proved that the earth was first 45,000, then 100,000, then tens of thousands, hundreds of thousands, and now billions of years old, that as that number grew, it put pressure on Christians who assumed that these conclusions of age were valid and correct. And so then they said, well, we have to figure out some way to fit the Bible in with these long ages. What I'm demonstrating tonight is that the theories of dating, all these various, from carbon-14, potassium, argon, all of these various techniques that are used to date the minerals are all based on false assumptions. And as we see in this fourth assumption, it's based on an assumption that predetermines the conclusion. They're not neutral. The methodologies themselves are predicated on a false assumption that is inconsistent with the Scriptures. So if you're a believer and you believe the Bible, you can't say, well, what about all of this evidence out there? Well, that evidence is preconditioned by assumptions that the earth is already old. So we have to stick with what the text says, what the Scripture says, and not on the basis of what atheistic science suggests. Now, one of the more interesting studies I ran across has to do also with the Grand Canyon, and it has to do with two different groups of basalt rock. Basalt rock is also an igneous rock that is found in the Grand Canyon. At the base of the Grand Canyon, and here is a schematic showing the Grand Canyon. At the base you have the Cardenas basalt, which is Precambrian, and I don't know if you can read that up on the screen, but this lower right-hand corner gives us the basic data. That as they tested the rock, they did 5 tests using the potassium-argon method, which yielded dates of between 791 million years and 853 million years. Then, that's called a model age because of the way they came up with that technique. Later studies, using a rubidium-strontium method, came up with an age of 980 to 1,100 million years. 1,100 million years is basically 1,100,000,000 years. So you can see there's quite a discrepancy between those two models. Then, as they developed a system to handle discrepancies, they came up with another method called the isochron method, which used multiple analyses and then charted a mean in those various specimens. It seemed like the theory was valid, but it has problems with its dating. The result of the potassium-argon isochron age was that it yielded a date of 715 million years, but the rubidium-strontium isochron age was a little over 1 billion years. So you can see there's a vast discrepancy in those ages. Now, this is the rock that's at the bottom of the canyon, so this would be the oldest rock. And it would take years before the upper rock, and the rock at the top was from a much more recent volcanic activity. Now, if you look at the data, I don't know, can you read that from the back? If you look at the data up here, this gives you the samples of the dating that was done on the rocks at the top. Now, remember, it's in this area that we talked about earlier, the area of where they had dated the rock and had come up with a figure of approximately 10,000 years. And there's also evidence that of this volcanic activity in the living legends of the Indians who lived in that particular area. So you have potassium-argon model that yields a 10,000 year date. Then you had 6 different potassium-argon tests on the olivine, which yielded dates from about to around 117 million years. So that's quite a discrepancy. Now, according to the chart that's up there, they did a test of 5 rubidium strontium samples to come up with a model age, and that yielded an age of 1.2 billion to 1.3 billion. Now remember, this is recent rock on the top, and yet it's older. Notice, the oldest date in the bottom is 1.1 billion. The date on top goes from 1.2 billion to 1.3 billion. And when you come down and look at the isochron test, the rubidium strontium isochron test yielded an age of 1.3 billion, and the lead isochron age, I don't know why I keep wanting to call it iron, the lead isochron age yielded a date of 2.6 billion. So you can see the tremendous inconsistencies in that dating system. So that's the oldest rock at the top, yet it's found in what's supposed to be the youngest part of the system. That's a look at the area that we're talking about on near the for the basalt rocks, the lower level and the upper level. Now, I just want to, before we close, I want to say one thing about carbon-14. That's the most popular system that most people have heard about, but it's the one that has the most problems. It makes all the same assumptions as other forms of radiometric dating, but its dating is not accepted, especially if it goes back very far. One quote from Robert E. Lee in an article entitled Radiocarbon, Ages in Error, published in the Anthropological Journal of Canada in 1981, states, "The troubles of the radiocarbon dating method are undeniably deep and serious. Despite 35 years of technological refinement and better understanding, the underlying assumptions have been strongly challenged, and warnings are out that radiocarbon may soon find itself in a crisis situation. Continuing use of the method depends on a fix-it-as-we-go approach, allowing for contamination here, fractionation there, and calibration whenever possible. It should be no surprise, then, that fully half of the dates are rejected. The wonder is surely that the remaining half come to be accepted. No matter how useful it is, though, the radiocarbon method is still not capable of yielding accurate and reliable results. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates. In other words, let's pick the ones that validate the theory and ignore the others. Now that gives us some idea of the problems that exist with all of these technical dating methods, but that's not the only ways in which evolution is used to measure time. And as we close out in the last few minutes, I want to just summarize 2 or 3 others that come up, and then this should wrap up our study of time. One way in which they measure, as I said earlier, measure time is to measure certain processes that go on today and then extrapolate it back in time. Well, the gravitational fields of the sun and the stars pull in, and like a vacuum cleaner, they just suck in cosmic dust. It's like a big Hoover in the sky, and this is called the Poynting-Robertson effect. The sun sucks in about 100,000 tons of cosmic dust every day, and if we could just harness that, that would probably keep the dust out of our homes. But now here's a conclusion: if the sun is millions and millions of years old, then the solar system should be sucked clean. All that, it's been vacuuming up the solar system for millions and millions of years. There shouldn't be any cosmic dust out there. In fact, based on the Poynting-Robertson effect, the sun and the solar system must be less than 10,000 years old. Another issue in dating has to do, and these last few points I'm going to bring up relate to astronomy. No one has ever seen the birth of a star. Evolutionists postulate that every year 2 or 3 new stars are born. That's just pure guesswork. We witness this death of stars every now and then in a nova, but we never have witnessed the birth of a star. Every once in a while, about once a decade, they'll come out and they'll say, we see a star being born. Then about 2 or 3 years later, it doesn't get any press or publicity, and they say, no, we were wrong. There's never been any evidence of a star being born. Why? God is no longer creating. It's done. It's over with. You're not going to see it happen. Now, another major problem with dating has to do with starlight and time, and I've briefly mentioned this in the past, and I want to make sure we get the evidence on starlight and time. The problem is that light travels at a rate of 186,000 miles per second in a vacuum. Now, that doesn't tell us anything about how it travels under other conditions. The problem is this. If light travels that fast, wouldn't it take millions of years for light to travel from the most distant stars and galaxies, which are supposed to be 200 or 300 billion light years away, to the Earth? And what about a star that is so far away, and let's say 100 billion light years away, that the nova, or let's say 100 million light years away, that if we see it nova today, doesn't that mean that that star actually died 100 million years ago? If light travels at 160,000 miles per second, then it will travel about 6 trillion miles in 1 year. That is the distance of a light year. That is what we mean by a light year, the distance light travels in 1 year. Now, there are galaxies that are alleged to be billions of light years out from us in space, and that means that light which left that galaxy 5 billion years ago should just now be reaching us. And that would indicate that the universe and creation must be at least 5 billion years of age. And if, according to the Bible, stars are only 6,000 to 10,000 years old, then light from those galaxies that are supposed to be 5 billion light years away would not even be reaching us yet. You see, that's the problem. Now, there are 4 possible solutions. The first solution is that God created the light beam with the appearance of age. In other words, God created it so that He created the galaxy 5 billion light years out there, and He created the light all along the path so that it instantly appeared on the earth. That's one solution. The second solution is that the distance to these remote stars has not been calculated correctly. This is possible. Distances are based on measurements using basic assumptions of trigonometry, that if you have a triangle and you know the length of the base and the 2 angles off the base, then you can measure the height of the triangle. And that's a method known as triangulation. And since the angles are so minute when you're dealing with a star that is 1 billion or 5 billion light years away, that what they do is they'll make a measurement when the Earth is at one side of the Sun, one side of the orbit, and then when it reaches the other extreme of the orbit, they'll take another measurement. But even then, you're dealing with angles that have an extremely low difference. And so there is just a minute error in your calculation can throw you off by probably millions of light years. Another problem is the nature of outer space itself. The major question here is outer space straight or curved? Is outer space straight or curved? If you think of outer space as straight, then it works according to the principles of Euclidean geometry. And all calculations are then straight line calculations, and the light that travels from a distant galaxy to Earth travels in a straight line. However, Euclidean geometry is not the only type of geometry. There are many non-Euclidean types of geometry, and these types of geometry are based on the assumption that space is not straight, it's curved. And so when you study geometry and you study the principle that the shortest distance between 2 points is a straight line, that's only true in Euclidean geometry. But you see, the Earth is curved, so there's no such thing as a straight line. It's always curved. So you have to introduce that whole factor in there. Now, one type of math that is used to measure distance in outer space is called Riemannian math. And according to these principles, the distance to the farthest star is much, much smaller than what you would get from a Euclidean formula. Dr. Wayne Zage, in an article entitled The Geometry of Binocular Visual Space, published in Mathematics magazine in November of 1980, observed 27 binary star systems and concluded that it appeared that light traveled in curved paths in deep space. If Euclidean straight-line math is converted into Riemannian curved math, light could travel from the farthest stars to Earth in 15.71 years. Not 200 billion, or not 5 billion years, but in 15 or 16 years. So this is very much a part of the debate, and there's no way to truly solve it sitting inside the system. But more and more evidence supports the Riemannian method of measuring the speed of light. Now, another view, and I caution you, the evidence for this may be suspect. Scientists have been measuring the speed of light for over 300 years now, and it appears to be slowing down. So based on extrapolations of the declining speed of light, you can measure the decline over the years. Then you can extrapolate back to 5,000 years ago, or 6,000 years ago, when God creates the heavens and the earth. And if that's true, then the light from a star 5 billion light years away would arrive on Earth in just 3 days. Now that would make sense in a creationist model, because the laws of physics that are operating during that week of restoration are not the laws of physics that are operating today. And that takes me back to a point I slipped past me on the dating of the igneous rocks. When you look at what's happening in the creation process on the second day when God brings forth the dry land, you can imagine the upheaval, the pressure, all that is going on geologically during that time that is non-repeatable and non-verifiable. And so that would cause the rocks to have the appearance of age, even if the dating system is correct. It's not starting out with the same information. Now, one final comment on dating, because there's a lot of geologists who think, well, you just have to have millions and millions of years for petroleum to form. On August 18, 1986, U.S. News and Wool Report stated that last year, that would be in 85, in the Gulf of California, MIT's Edmond found that the action of hot vents in the ocean was turning dead plankton in the sediment into petroleum, a process that normally takes at least 10 million years, squeezed into an instant. See, that fits a creationist model, that these events don't take millions of years. In various cataclysmic situations, they can be produced in days or weeks, if not seconds. In conclusion, there is no solid evidence for lengthy ages of the earth. It's all based on assumption and guesswork, because at the very core is a rejection of a sovereign God who rules in human history, who is calling sinful and rebellious creatures to account for their sin. Romans 1:18, for the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men who suppress the truth in unrighteousness, because that which is known about God is evident within them, for God made it evident to them. For since the creation of the world, His invisible attributes, His eternal power and divine nature, have been clearly seen, being understood through what has been made, so that they are without excuse. For even though they knew God, they did not honor Him as God or give thanks, but they became futile in their speculations, and their foolish heart was darkened. Professing to be wise, multiple PhDs, IQs off the charts, they became fools, and exchanged the glory of the incorruptible God for an image in the form of corruptible man and of birds and four-footed animals and crawling creatures. With our heads bowed and our eyes closed. Father, we thank You for the clarity of Your Word that gives us a framework for being able to interpret history, for being able to interpret the creation around us, for being able to discern that which is true from that which is false. Father, we pray that You would help us to understand the things that we've studied this evening, that we might have our faith and trust in your word strengthened as we realize that the challenges of the human viewpoint pagan thought systems around us have deep flaws and are contaminated by their atheistic presuppositions. We pray this in the name of Jesus Christ, our Lord and Savior. Amen.